Hello. It's been some time now. This is the academia series. It has been some time now. You haven't heard from me. By that, I do this presentation on balancing of chemical equations. So I decided to just do that. Please do not forget to subscribe to the channel, Academia series on YouTube. I have other presentations for the JHS. But now this particular presentation is on IB and IGCSE chemistry. That is the British curriculum chemistry. Today we're going to look at another interesting topic on redox and balancing of redox equations. Now, when we say redox is an acronym for a reaction in which oxidation and reduction occurs simultaneously. That is, in that particular chemical reaction, oxidation is occurring and reduction is also occurring as well. So the word redox was coined out of red for reduction, ox for oxidation. So when I say a redox reaction or a redox equation, it means a reaction in which both oxidation and reduction is occurring. Now, for you to be able to master balancing of redox equations, there are some things that you must first know. Number one, you must know which part of the reaction is undergoing oxidation and which part of the reaction is also undergoing reduction. And talking about oxidation and reduction, we have three different ways that we can determine this. The first one is in terms of oxygen and then hydrogen. We can describe a reaction as being oxidation reaction or has undergone reduction depending on the movement of oxygen and then hydrogen atoms. We can also determine this by the electron transfer, which species lost electrons and which species gained the electrons. We can also use the oxidation number or state of the species to describe whether it has undergone reduction or oxidation. Now let's look at oxidation and reduction in terms of oxygen and hydrogen. And oxygen, when it is combined with an atom, makes that particular atom undergo oxidation. Or we can also say when that atom, hydrogen has been removed from it, that one also constitutes oxidation. So at the simplest level, oxidation is considered to be a reaction in which a substance combines with oxygen, or in which a substance, there is a removal of hydrogen atom from the compound. Let's take these two examples so that we can see that here, we can see from here that magnesium has combined with oxygen. And now we have magnesium oxide. This one we describe it as being oxidation. We have iron also combined with oxygen to form this is also oxidation, the combination of oxygen atom, or the removal of hydrogen atoms. Now we have HCl here. After the reaction, we have realized that hydrogen has been removed from the chlorine. So we can say chlorine has undergone oxidation reaction here. We have for methanol, we have 4 hydrogens here. After the reaction, all of these hydrogen have been removed, and we have that. So this one also, we can say the methanol has undergone oxidation. The reverse of this reaction constitutes reduction, and that means removal of oxygen and addition of hydrogen. So in terms of oxygen, hydrogen atoms, when the oxygen is added to a species, it undergoes oxidation. Or when hydrogen is removed from an atom or a compound, that particular element also undergoes oxidation. Then when oxygen is removed, or when oxygen is removed or hydrogen is added, that one constitutes reduction. Now let's look at in terms of electron transfer. So that in terms of electron transfer, when a species loses an electron, it becomes oxidized. So we are using the acronym OIL. Oxidation is loss. Then when a species gains oxygen, gains electron, that one is considered to be reduction. So reduction is gain. So gaining of electrons constitute reduction. The loss of electrons constitute oxidation. Then we can also describe oxidation reduction in terms of oxidation numbers. An oxidation number is the charge that an atom carries or seems to have, either when it is in the elemental state or in the compound form. So that when your oxidation number seems to have increased, we say you have undergone oxidation reaction, whilst a decrease is reduction. And as I've said previously, when you gain oxygen atom, when you lose hydrogen atom, or you lose electrons, all this will result in your oxidation number being increased. And that is oxidation state. Or we can say that one is oxidation reaction. When you have loss of oxygen, gain of hydrogen atom, and then you gain electrons as well, this one results in decreasing oxidation number or state, and we say that one is a reduction reaction. Now, for you to master, or the first step in balancing redox reaction is to separate them into oxidation half and reduction half. And for that, you must be able to determine the species oxidation numbers so that you can know which one has undergone reduction and which of them has undergone oxidation. And for you to perfectly do this, you must be able to calculate the oxidation numbers. Fine, looking at whether oxygen has been added or removed, it gives you an idea which one is oxidation. Whether you have lost electron, gained electron, that one also gives you an idea. But to be specifically and accurately determine that this is your oxidation number, it has increased or decreased, you need to apply what we call the oxidation rules. And these are the oxidation rules. This is a summary of it here, but let's take it one after the other. So that the oxidation number for any atom in the uncombined state, please, I need to make some uncombined. In the uncombined state, that one constitutes, in the uncombined state, we say the oxidation number there is 0. If I say uncombined state, it can be oxygen in its natural or molecular state, oxidation number is 0. I'll give you more examples on that. Sodium metal is 0. Hydrogen in the gaseous state is 0. In the uncombined or elemental state, your oxidation number is 0. Then for a simple ion, such as chlorine ion, ion 2 plus ion, for these simple ions, if you want to know the oxidation numbers, it is equal to the charge on these ions. So as you can see here, chlorine is -1 and ion is +2. Please, the way we write the charge on the compound is different from the way we write their ions. So you can see here is 2 plus, but then in writing the charge, we say +2. For a neutral compound, that is oxidation number rule number 3. The sum of oxidation numbers of the element is 0. That is, when you take a compound and it's neutral, that's the whole compound doesn't carry a charge. After summing up all the individual oxidation numbers, you equate it to 0. I'll take this into details very soon. Let's look at oxidation number for 4. For a polyatomic ion, that is an ion in which contains so many elements combined together to form that ion. For example, SO4 2-, CO3 2-. This is a polyatomic ion. Here, after summing all the oxidation numbers of the individual element, equate it to the charge on the ion. I also take this one into detail so that I explain it better. For hydrogen, it can combine either with a metal or a non-metal, or it can behave as a metal, and sometimes in the compound, it can behave as a non-metal. in this case, when it combines with a non-metal, then hydrogen will have oxidation number of +1. But then when it combines with a metal such as sodium here, it will have oxidation number of -1. Then lastly, we have oxygen atom. Oxygen atom in all compounds will have oxidation number of -2, except in few compounds such as hydrogen peroxide. As you can see, example is what we have here. Over there, the oxidation number is -1. And then in superoxide, over there, the oxidation number is -0.5. All right, now, as I said, let me throw more light on rule number 3 and rule number 4. But before I do that, please take note of this. There are some compounds, when you see them, for example, I want you to take note of these various compounds. OH minus, it exists as a unit, so we don't separate it. Whenever you see it, their oxidation number is -1. Then we have NH4 plus. This one also exists as a unit, with oxidation number for the whole unit being +1. Then you may see H2O in a certain compound. Please, the oxidation number for water is always 0. I want you to take note of this carefully. Now, let me then throw more light on rule number 3 and then 4. On rule number 3, for example, we may have sodium tetraoxosulfate 6 as on the screen. For example, if you are to calculate the central atom, we say the central atom is what? X. Now, we know sodium has, because it is in group 1, it will have oxidation number of +1. So times 2. We see 2 here. We have said that let the oxidation number of the central atom be X. So X times 1 for sulfur. Oxidation number for oxygen, I told you, is -2. -2 times 4 for oxygen. Now, because this is a neutral compound with no charge on top, we equate it to 0. So that's what rule number 3 is saying, from which you can calculate, and then the oxidation number for sulfur is +6. So when there is no charge on the compound, after summing up all the individual oxidation numbers, equate it to 0. Then we have rule number 4. This is a polyatomic ion. Polyatomic, 2 atoms combining together to form an ion. We call it the polyatomic. Over here, when you sum up all the individual atom oxidation number, equate it to the charge on the compound. So you see that here it is equal to -2, because we have 2 minus on the compound. All right. Now let's work out, now that we have the rules, let's apply it and work out some oxidation numbers. Let's work out some oxidation numbers. Let's look at a compound like, okay, let me pick up my pen, so that we have something like K2Cr2O7. Now, the central atom here is chlorine. We pretend we don't know. Let the oxidation number be X. Potassium being group 1 has an oxidation number of 1. So we have 1 times 2 for potassium. Plus, then we have chromium. So X times 2 for chromium. Plus -2 for oxygen times 7. Now, because it's a neutral atom with no charge on top, we shall equate it to 0. So we have 2 plus 2x minus 14 will give us 0. If we work out this, you get x to be equal to +6. So the oxidation number for chromium is +6 over here. Let's take another one. Some more examples here, so that we can have, let's see, another example like, we have, let's say, 20. Let me give you this as well quickly, so that we have 2 plus. Over here, it is a single atom. And I said that from rule number 2, it is equal to the charge on the ion. It's a single ion, so just a charge. So over here, oxidation number is plus